Hey everybody, your friendly math tutor here with the SAT Daily Challenge, Thursday, May 14th, 2026. So we have a quadratic function here, and what I want to do is I want to use Desmos for this. But I want to show you, when we use Desmos table for quadratics, we really need 3 points that we're certain are on to get a unique parabola or quadratic function. So the cable reaches a minimum height of 20 at a horizontal distance of 120 feet from the tower. So that is the coordinate pair 120, 20. So however far x is, right up here it says x is the horizontal distance, right? So that's why I put 120 first. Then it tells us at x equals 0, it's 110 feet. But that's all it gives us. And then it asks us something about 190. So basically it says that 190, what is the height? Okay. Well, we need more than 2 points to get a quadratic if we're going to do it in Desmos. So what I'm going to do is use symmetry. The fact that if it reaches its vertex, so imagine we have a parabola like this. So if this is 0, 110, and then this is 120, 20, then there's a point over here that's symmetrical with this point. And that point is going to have the same y coordinate and then just be double the distance from 0 to 120. So if I go from 0 to 120, then I go another 120, so I'm going to be at 240. So if they ever give you 2 points on a quadratic and you want to use the Desmos table, you can typically use symmetry to find the third point. So now I'm going to do the rest of this in Desmos. I'm going to show you how to do that. So we are going to add a table. And then we're going to put the point 120, 20. Whoops. Then the point 0, 110. And then the point 240, 110. Then we're going to do quadratic regression. Okay. And that gives us an equation. Okay. Now I want to know what happens at 190. So I have two options for this. I am going, what I could do is I could copy this. Actually, let's just see what happens here. So I'm going to export it, but I'm going to change it so that it says f of x. And then I'm going to do f of 190, and that gives me the answer. So that tells me that the height is 50.625. So then I jump back, and it says to the nearest foot. So 50.625 is what Desmos gave me, and to the nearest foot is 51. So the answer is 51. I'll hop back to Desmos to show you the other way to get it. I went back and forth between the ways. The other way to get it is to, instead of doing this, just graph the line x equals 190. I was in all caps there. Oops, now I'm all over the place. Just graph the line x equals 190, and we're going to see where it intersects. The downside to this method, though, is I have to zoom out a bunch. Not a whole bunch. And there you go. So that's another way for me to get 50.625. But we end up rounding it, so it's 51. All right? Hope that helped.